All right, we're continuing here with the central limit theorem, and we have a transition now to what happens with proportions. We've had a little bit of discussion with central limit theorems and means, but what about proportions here? So I have a question that says, suppose the true proportion of voters in the county who support a restaurant tax is 0.53. Consider the sampling distribution for the proportion of supporters with a sample size of n equals 110. What is the mean of the distribution, and then what is the standard error of the distribution? Now, the mean of the distribution here, since we're talking about a proportion, is the proportion. And with the central limit theorem, since we know the proportion here is 0.53, that is going to be the mean here. Now, the standard deviation is where it gets a little bit different. The standard error of the distribution, becomes it becomes the new standard deviation with a normal standard distribution involving proportions. So I'm going to paste this up here and then we'll talk about it. So we had a change in formulas when we used means, and there's something similar here for proportions. With our proportions, the new standard deviation, so our old standard deviation, I don't think we've actually talked about this. So we have a new standard deviation called the standard error of the proportion here, or the standard error of this distribution. Anyway, the standard error of the proportion is going to be the square root of p times q over n. Now p for this one is this value we're given here. And the mean of our proportion, since we're dealing with proportions, it really is p. So in this one, our standard error would then become, standard error, it'll become, well, there's a few things I should check out ahead of time here. P, the probability of success here, 0.53. Now, Q is 1 minus P, and that's going to be 1 minus 0.53 here. And then N is our sample size, in this case 110. So then the standard error becomes the square root of P times Q over N, and if you want, 0.53 times 0.47 over 110, just so you can kind of see it with the numbers there. It kind of makes it make a little bit more sense, I think. We get this. Okay, somehow bolded that guy. All right. Anyway, now the pictures for these get a little bit dicey. I'll try to draw one anyway, but our normal distribution gets switched like this, and here in the middle is our 0.53. Now our standard error is a really tiny number, 0.0475, and so if I take this and I subtract 0.04, somewhere over here is going to be like 0.57, and here 0.49, subtracting those out of there. But these are the answers for this question, and a little bit about how standard errors, or central limit theorem as it applies to proportions. So, based on historical data, your manager believes that 29% of the company's orders come from first-time customers. A random sample of 77 orders will be used to estimate the proportion of first-time customers. What is the probability that the sample proportion is less than 0.27? And then we have a note here, z-scores, on how to do those if you need it. So I'll snag this here, hop over to Excel, and we have a little bit more happening now in this one than our previous. So based on historical data, our manager believes this 0.29. So this is our p-value, a simple random sample of 77 orders, and I'm given a little bit of room for Q. Now, you can kind of do these in your head if you like to. You don't necessarily have to here. And then now we have a sample proportion of interest that's 0.27. And so I'll draw my normal distribution. Maybe. Sometimes it gets a little wild here. Let's see what happens. Okay. So I've got a 0.29 in the middle, and I didn't figure out what my standard error is yet, but we'll just say this is over here. Now this is 0.27, and we're looking for less than, so that's this area here. Now proportions can get a little bit tricky here because we have proportions, and then we have means, and we have proportions. So you want to be a little bit careful. This proportion here is different than this proportion here along the bottom. And that's why I say these can get a little bit dicey because we have proportions everywhere. So I got P times Q over N. And I just like to let Excel do all the work there. So the probability that my proportion here is P hat, I think is what we use for this one, less than 0.27. And so treating this like it's normal, I've got a normal distribution. 0.27 is the value I'm interested in. My mean is 0.29, and my standard deviation is the standard error here. And then true gets me the area to the left. So proportions tend to behave normally, or at least that's how we're going to handle them in this class, because for the most part it's really true. So 0, 3, 4, 9, 5 as my answer here. Okay, I might try to squeeze one more example in just to see what happens. So based on historical data, your manager believes that 30% of the company's orders come from first-time customers. A random sample of 93 orders will be used to estimate the proportion of first-time customers. What's the probability the sample proportion is between 0.26 and 0.45? So here we go. So our p-value here is 0.3. This is really kind of like our mean, right? But it's our p-value. Q is going to be 1 minus that, which is 0.7. And then N is 93. And we can get a standard error here, the square root of P times Q over N. And now I'll try to draw the picture. So 0.3 is in the middle, and I'm looking to figure out between 0.26 and 0.45. And I've got this between action, total miss there. This is what I'm looking for here. So probability that we're between there, 0.26 is less than p hat is less than 0.45. So I've got a normal distribution, and I take my high side, 0.45, my mean, my standard error, true, that's the area to the left, and then I subtract, normal distribution again. Now I've got my low side, 0.26, my mean, and my standard error. Oops. My Uh-oh. Well, my mean, my standard error, and true. So here's a value. I got to round it to 4 decimal places. I got 7992, and the 2 is followed by a 4. So there we are with an answer. So I hope that helps. A couple of the questions worked out with proportions. We can do the normal inverse and figure out a proportion. Those get kind of even more wild because we have percents up here and percents down here. Proportions, in all the places. So just be really careful as you work through these. And picture is super duper helpful. So make sure you use one. Let me know if you have any questions. Good luck.